Hello everyone. So today we are going to understand the RAG for LLMs. What actually RAG does for the LLMs. So why it is needed. So let's understand our basic scenario. Like let's say how we study. We study one book and give one exam with a less efforts. The same scenario, if we study multiple subjects, we need to read multiple books. Even for the same exam, we can read multiple. Even for the same exam, we can build we can read multiple books and attend the exam. So here efforts are increased. So here your if we go and calculate your brain usage, then in that case here it will be comparatively less than this second scenario. So the same thing happens with the LLMs also. They also need to process your data, so they also need to read your context either from the web service or web search that is available on the net, or we need to provide something based on the user query. Along with the user query, you need to provide something. So based on that, it will analyze the data and it will answer your question. So let's say this user asks any question, it will just search on the web, or it can refer the trained data and it will give the simple output. So here processing will be negligible. But when we go with the context, if we provide any PDF file or document to the ChatGPT along with the query, in that case ChatGPT has to read this file and understand this, and based on that it should understand the query also and generate the context. Comparatively, as we are giving one file only, the context will be small as we are comparing the like with the small file only, let's say 10 pages, and so it will be a small context and it will not take more processing time, but comparatively it will take more time if you compare it with this one first scenario. So assume that if we have 10 files and we have to give all the 10 files to the chat gpt, and it should understand everything from this file and then it should generate the content. So here what happens, the context increases and the gpt will go out of reach limit or rate limit, or it will be a more complex thing for it to process all the data and generate the proper answers for you. So how to fix this issue? So for that, this RAG comes into picture. So here RAG means we are just giving a memory or a knowledge base to this chat GPT models, so they can just go search in the chat GPT. So let's say here it is LLM, and it will go and check the knowledge base, and it will bring back answers and send it to the users. Okay, so let's understand that scenario. So before RAG, what we can do currently, we can just take 100 files having 50 pages per file equals to 5000 pages context. So it will be a huge context for this one single query, and it will be a difficult or time consuming or very complex for a LLM to process this data. Okay, and then generate your answers based on your query, and it will send you the answers. So this looks like is simple, it will work, but it is not a good way to implement. So there should be a process where if these files are going to be used again and again, and this should be there, and we should not sending it along with the query every time. We have to store it somewhere, then LLM can use it for each query and send answers to our query. So let's say how we can implement the RAG. We have the same 100 files, 50 pages per file, that is 5000 page context. So all these 5000 pages will send or divide it into smaller parts. We call it as chunks. Then chunks will look like this. This is a visualization of the chunks. So you can imagine like these are the big files and we made it smaller. Okay, so we created a small part of each file. It will look like this, based on or using vector embedded LLMs. So that model we will use for embeddings, and it will send to the vector DB. What do you mean by vector DB? So these are considered as a vectors, and these will be stored directly in this database. So it will be stored in this database directly along with the metadata, vectors with metadata like pages, numbers, documents, everything. This file will be there, but it will be splitted into smaller parts, and it will be arranged in such a way that this LLM can find out the proper chunks based on the user query. So first thing is we need to create this scenario, or we need to implement this part. So vector DB will arrange this in such a way that the LLM or GPT can search it in a vector database based on the query, and it will find out the relevant data, and it can send back to the user. So this is the first scenario that we need to implement. So this is the RAG. This is called RAG. So we need to process all the documents into the chunks. Then it will become a small parts of the file. It will be stored in a vector database. So this is the first part. Now all the context, all the 5000 pages are available in the vector database. So here, once all the 5000 pages are available in the vector database, now we have the large context, large memory for this LLM or for the agents. So what will happen when user asks any query to the ChatGPT or our model, it will divide or it will convert that query into a vector embedded query, again a tokenized query. So it will go along with this request, and it will search for the relevant chunks. This part should be present in some of the files, so it will just find out all the relevant text based on this query, and it will fetch all the data, all the files, and it will send it to the user. So here, this process we called similarity search, vector similarity search. So embedded query helps to generate accurate data from the vector database, and user will receive a accurate answer for his query. So let's say now the issue is solved or not. Yes, issue is solved because we are not sending all these files along with the user query. User is just asking the query, then LLM agents are searching for the answer in the vector database and giving answers back to the users. So this is the simple way, and we are just reduce the number of tokens that we consume in our old scenario, but here we are consuming less data, and we have our LLM model that has the context already, and it can use as a knowledge base for each query. So this is how the simple RAG has been implemented. So in the next part, I will show you the accurate coding part of it, how to create a RAG for any agent on your local machine. Thank you.